So our first test is going to be Thursday, February 8th. So that's a week from this Thursday. So you have about 10 days to get ready. So we are going to have a review on on Tuesday, the 6th. So a week from today, we will do a review. But you guys don't rely on that review alone. You should start already making sure that you are understanding the material, that you are comfortable with the material. So I always say when you're doing your homework and your quizzes, don't just get through it. If you're just getting through it, you're not learning the material. Or if you're waiting till Sunday night or Monday to do your homework, you're literally just getting through it, because sometimes it takes longer than what you expected. So make sure that you are taking the time to practice, do similar exercises. Even on the quiz, if you get 100%, you should still try it that second attempt. Obviously, the highest grade goes to the Canvas grade book, so don't worry about that. But the more you practice, the more comfortable you're going to be with the material and the better you're going to do on the test. So what happens a lot, and this is very, very common, is, you come into the first test and you're like, man, I'm doing great. I'm getting my homework done. I'm getting, 80s and 90s on my homework, and 80s and 90s or 100s on my quizzes. Man, I'm at an A. And you don't practice and you don't really know your material. You just got through the homework and you were able to answer the questions correctly based on, maybe like on the homework, maybe you took 3 times to be able to do it. Or maybe you are just copying and pasting. And that happens a lot where you're using the show me an example too much. So make sure that you're not just copy pasting, because when you get to the test, there is no copy paste. Okay. So make sure you're very, very ready, because what happens is you take your first test, you don't do so well, and your grade tanks. So you can go from an A, take the test, not do well, and it drops to a D very quickly, because the tests are worth so much. They're worth 50% of your grade. So if you are not taking this very, very seriously and making sure that you are doing everything in your power to do well on the first test or on every test, then it's going to bite you in the butt. And I've had this happen more than once. So just trust me on this. You don't want to get bit in the rear and be surprised that, oh my gosh, I was at an A and now I'm at a D. How did this happen? Well, I'm telling you right now, that's how it happens. Is you go into the test thinking, oh, I'm got an A. I'm not gonna, I'm not gonna worry about it. So I think that's the big difference, especially from high school to college. Is high school, and I don't agree with it at all, is they are required to pass, like, I don't know, 90% of their students. So they let their students take the same test over and over and over and over again until they can pass the test. In college, that is not an option. Okay. In college, you want to, you get one chance at the test. So you have to go into the test knowing your material. Don't wait till after the test to go, oh my gosh, what do I need to change? So make sure you go into the test knowing the material. So with that said, you get to use a page of notes. Okay, now if this was a face-to-face test, I don't allow examples. And the reason I don't allow examples is because that's copy and pasting. Right? You have an example and you have the question and you're just copying and pasting without really walking through the process. So I am going to have you turn in your notes. So make sure that your notes don't have any examples on them. And then I also have, let me share my screen. I also have a formula sheet. So don't waste your page of notes on a formula sheet. So let me show you where that is. So here's our class, here's our module, and let me see. So down here at the very bottom of module 1, we have test 1 formula sheet. So this is what it looks like. And you can copy it or you can print it if you want. So there's the difference quotient. There's the definition of a derivative. there's the power rule, which we're going to go over today. Here's the, cost, revenue, profit functions and how to do it. Notice you have to know how to read this. Like this marginal average cost, marginal average revenue, marginal average profit. This is all 9.7, which will probably start today. We won't finish it, but we'll start it today. So I'll explain to you how to read all of this. But this is your formula sheet. Okay, so it gives you everything you need. So don't waste your notes on formulas. You have all the formulas you need right here. Okay. What I would suggest when you're writing your review, or I'm sorry, your notes, and 8.5 by 11, don't get, a giant poster board, just 8.5 by 11. People ask me all the time, can we write front and back? I don't care. It's 1 page of notes. Do what you want to do on the 1 page of notes. And make sure you don't have an example. You can write out like the process, but no example, no step-by-step examples. And I will be having you turn in your notes as well as the work. So what I'm going to do, and I'll explain this again next week, and we'll walk through it. Hopefully on Tuesday, we'll walk through the process. But I'm going to send you like this, a test. So it's going to be a written test. We're not going to do our test on my math lab. So I'm going to actually grade it. I get a better sense of your process when it's like a paper exam. So I'm going to give you a paper exam. So I'm going to send it to you. You can either do it just on your own paper, or you can print it and write on the printed form. And then you're going to scan it, save it, and send it back to me. And it will go into, let's see, close this. It will go into your submit. Where is it? So this is under tests, under your, oh, I don't have it yet. Okay, under tests, you'll have you will have a link that says submit work for test 1 here. And I'll put that in today. I can show it to you in my online classes, what it's going to look like. Taking a while. I was panicking this morning because my internet went out, and I went, oh man. So this is what you'll have. Test number 1, submit work here. So that's what you'll do. You'll click on it, and I'll walk you through the process on Thursday to make sure everybody can submit it correctly. Okay. So scanners, there's Cam Scanner, which I have an Android phone. Cam Scanner works great. It works great for both iPhone and Android. But iPhone has a scanner built in. It's under Notes. And so if you go into Notes, click on the camera, and Orlin and Dylan and Adam have done this from last semester. So you guys, the difference is I'm not going to do my math lab test. We're going to do a paper test. So that's going to be the difference. So it'll be a little bit different than what we did last semester. Okay, so any questions on the test itself? No? Nope. Okay, all right, so what we're going to do today, this is 9.5. So homework 5 is a combination of 9.5 and 9.7. So we're going to learn the differentiation, basic differentiation skills, and then we're going to apply those skills to word problems and marginal cost, marginal profit, marginal revenue. Okay, so when we're doing these, this is everybody's favorite section, because if you've had calculus before, you understand that there's shortcuts to it, right? This is the definition of the derivative. That's what this formula is. The limit as h goes to 0 of the difference quotient. Okay, so what we're used to doing is, let's say we have, this is our function, right? If it was graphed, it would look something like this, right? It's a parabola, and it's centered at 0, 0. So that's our parabola. So remember, if we're looking for the definition of or using the definition of the derivative, we're taking the 4 steps, right? This is step 1, step 2, step 3, and then finding the limit is step 4. So if I do this all together, right? So this is just walking through the definition of the derivative, and we know that every time we see x plus h squared, we get this x squared plus 2xh plus h squared, right? So that is replacing the x with x plus h. Now I'm going to take this and I'm going to subtract off my original function. Okay, so when I do that, this negative gets pushed to here. So now I can cancel here and here. So all I have left is 2xh plus h squared, which is all the terms that have h. So that's this step here. And I'm sorry, my dog's going to bark. Katie, stop. Okay, and then the third step says take off the h. So I'm going to factor out an h. So on your test, this is super important. On your test, if the directions say, let me type it. If the directions say use definition of the derivative to find the derivative, this is the process that you have to take. Okay, you're going to walk through the entire thing and show me your process. All right, so this is dividing off the h. So this is this step right here. And then the last step is I take the limit as h goes to 0 of 2x plus h. So h goes to 0, so I end up with 2x. Okay, this is my derivative. All right, the derivative is the slope of any function that is the x squared function. So if I said x was -1, my slope right here would be a -2 slope. If I said that x was 1, my slope right here would be 2. It's positive. Okay, so I can use this to find the slope anywhere. So where this definition of a derivative, I'm going to put this down, where this definition of the derivative gets us into trouble is, what if I had a function like this? Like that. And I said, use the definition of the derivative to find the derivative. Well, you can see what a mess this is going to be. Right? This is my first step, and look how much work this is. So I would have to go x plus h times x plus h, that answer times x plus h, that answer times x plus h, and then do it one more time. Okay, so you can see it gets really messy. So what I had nothing to do with it, but what mathematicians way, way long ago came up with is what's called the power rule. Okay, so the power rule for derivatives. For derivatives. Okay, and here's the power rule. If given the original function of ax to the n, okay, this is our original function. Notice, Katie. Sorry about that. Okay, so put her outside. So if you're given an original function, and notice how I wrote it, right? F of x, it's the original function. Then f prime of x, so the derivative looks like this. I take my n, and you have to work with me on this one. I take my n and I drop it like it's hot. So all of you start singing Snoop Dogg's song, right? I'm going to take my n and I'm going to drop it to the front. Okay, so it looks like this. So now, now I'm going to multiply those two. So I get n times a, whatever a is just a number. And then I repeat the x. And then I do n minus 1. So I subtract 1 off of my original function. Okay, so once again, and so you want to make this a mantra in your head as you're doing this. You drop the exponent to the front and multiply, and then subtract 1 off of the exponent. Drop the exponent to the front and multiply, and subtract 1 off the exponent. Okay, so let me give you an example. Let's go back to this down again. Okay, so if you're given the function x squared, then the derivative, so now we're going to use the power rule. I'm going to take my 2 to the front and multiply. So 2 times 1, remember, if there's nothing there, it's a 1. So 2 times 1 is 2, x, and then I'm going to subtract 1. So 2 minus 1 is 1, x to the first power. Okay, well, we already got that. Do you see it? Put this out of the way. There's our derivative right there, that 2x. And that's a lot of work, right? That's using the definition of the derivative. Now, when we're using the power rule, our work is a lot less. But it works every single time. Every single time it works. So if I use this function up here, this one, so I'm given 5x to the 5th plus 3x to the 4th plus 2x squared, my derivative. And notice how I'm writing this. This is the original. This shows derivative. You have to get in the habit of writing it, because we're going to get to the point where sometimes we have to plug values back into the original, sometimes we have to plug values into the derivative. So you have to identify which one's the original and which one's the derivative. Okay, so let's use our power rule. And what's nice about this is we just do it term by term. Okay, so we look at just this first term. I drop my 5 to the front and multiply. So 5 times 5 is 25. And then x, don't forget your x. And then I subtract 1. 5 minus 1 is 4. Plus, do the exact same thing on the next one. Drop my 4 to the front and multiply. So 4 times 3 is 12, x, and then I subtract 1 to the third power. Oops. To the third power. Plus, drop my exponent to the front and multiply. So I get 4, x, and then I subtract 1, and I get x to the first power. So this is the derivative. Way, way, way faster than trying to do the definition of the derivative. Okay, so the good news is you only have to do the definition of the derivative when it says use the definition of the derivative to find the derivative. If it doesn't give you that instruction, then you can use the power rule. All right. The other good news is if you have to use the definition of the derivative, then you can check it. Did I go through? Did I, do all the algebra hoops that I had to jump through? And if I use the power rule, do I come up with the exact same answer? So there's a way to check now to make sure that the definition is correct. So you should never get that definition of the derivative incorrect. Okay, so any questions so far? And you're going to get lots of practice. You're going to get lots and lots and lots of practice.
No, we're good.
Okay, all right, so now, and again, I'm gonna move this down. Now we have to just review some things, okay? So if I wanna go from a radical to a fractional or rational exponent, remember we did this the first week. So remember we have, say we have the cube root of x squared. What would this be as a fractional or a rational exponent?
2 over 3x. I'm sorry, x to
There you
the
go.
2 over t.
Perfect. So x to raised to the 2/3. So remember, you're dropping that 3 right underneath, and that becomes your exponent. Now, the reason for that is if I give you an original function, and let's just say it's the same thing, right? I can't use the power rule on this. I don't know what I'm dropping to the front. Am I dropping the index? Am I dropping the 2? What happens to the radical? So I can't find the derivative when there's a radical. So every time you see a radical, you have to change it to a fractional exponent every single time. And then we can find the derivative. Okay, so make sure that you are super comfortable. What about this one? Make sure you're super comfortable with changing a radical to a fractional exponent. So what would this one become?
1/2.
Good. So it's x to the 1/2. So where did the 1/2 come from? When there's nothing there, the index is 2. When there's no exponent, it's 1. So we do the exact same thing. We take our index and we put it right underneath. Okay. Oops, where that came from. All right, so get real comfortable with that. So now we can find the derivative. Okay, so we do the exact same thing. We drop the 2/3 to the front and multiply. So we end up with 2/3 x. So here's where it gets tricky. I still am subtracting 1. Please don't do this on your calculator. It's a waste of your finger movements. Okay, what's another way to write 1 as a fraction that I can subtract?
1 over 1.
Okay, 1 over 1, but I can't subtract fractions without a common denominator. So what would be another way to write 1 where the bottom number or the denominator sees? There it is, 3 over 3. Perfect. Okay, so if this is 2/5, I'm going to subtract 5 over 5. If this is 2 over 1,000,000, I'm going to subtract 1,000,000 over 1,000,000. So when you're still subtracting 1, you're just adjusting because you have to subtract fractions. Okay, so what's 2/3 minus 3/3? It's a negative 1/3. Okay, this is my derivative. So remember, when subtracting fractions, right, the denominator stays the same, and all I have to worry about is the top. So 2 minus 3 is negative 1. That's where I get the negative 1/3. Okay, so let's try another one. What if I had f of x equals 3 times the square root of x? How would I rewrite that?
Three x to the 1/2 power.
Good. So 3x to the 1/2. So now to find the derivative, I do the exact same thing I've been doing. I drop this to the front and multiply. Okay, so this is where I'm going to do it off to the side. So 3 times 1/2. So it's 3 over 1 times 1/2, which is 3/2. So remember, when multiplying, you can just multiply straight across and reduce if you need to. So 3/2 x, and then we're going to subtract 1. So I'm subtracting 1, 2 over 2. So all I'm doing is I'm just matching my denominator. That way I can subtract easily. So I get negative 1/2. And there is my derivative without having to go through all the hoops of the definition of the derivative. Okay, any questions? Okay, So now a couple other reminders. So let me still.
I have
Couple other
I
things.
have a question, Professor Manchester.
Yeah, go ahead.
As far as when we take the test, what's more important as far as like showing work and I guess the correct answer? Is it like a situation where like if the work isn't done, then the answer is incorrect as well, or
Yeah, so on, especially on the test, I want to see everything because I want to see how you're thinking. Right? I want to be able to walk through your work and go, okay, he's got the right thought process here, he's got the right thought process here. So I would say show more than what you think you need.
okay.
If you're not sure, just show it.
Okay.
Okay. And I'll show you, like, because when we go over the review on Tuesday, I'll show you exactly what I'm looking for. Okay. And that's how you earn partial credit, that kind of thing.
Okay.
So like on this one right here, let's say you did this, you changed it correctly, and let's say you did 1/2 times 3 and you got 2/3. Well, if you show me what you're doing and I see, oh, you just flipped it over, I'd still give you partial credit because you did the right process, you just didn't multiply correctly.
Okay.
Okay. All right, and then let's see. Another reminder of what to do with it. So when you have negative exponents, so for instance, if I had x to the -2, okay, this in essence is 1 over x squared, right? It's the negative exponent tells you to flip it over. So I just flipped it over because this is like over 1. But I can't find a derivative of this. Right? So what do? That the denominator is x squared. I can't just do the power rule. So in this case, you're just going to leave it as a negative exponent, and that's totally fine. So now you do the same process to find the derivative. I take my exponent, I drop it to the front and multiply. And here is the tricky part. Then I still subtract 1. So what's -2 minus 1?
-3.
-3. So you have to be careful, right? You can't just automatically assume you're gonna you're gonna do it the same way every time. You have to do what it says. So this is -3. And then if I asked you to rewrite this, I would rewrite it like this. If I said write this, or if my math lab says write it with a positive exponent, the -3 is only on the x. So you drop that to the bottom and it becomes positive. Okay. So that's one way to write it. This answer right here is perfectly fine. If it doesn't tell you to write in positive exponents, this is a good answer. You can just leave it right there. You don't have to change it unless it asks you to. Okay. All right. So any other questions on just some of these? Okay. So these are the basic differentiation rules. So it's just some of the things that you need to understand. Again, this is all mathy, it's very mathy. So the constant function rule. So here's what this means. The constant function rule says, what if I had a graph, and you're going to pretend with me that this, well, I'm going to make it straight, that this is my line. Okay. So this right here is my line. I don't know why it changed colors. Okay, it's a horizontal line, right? What would be the equation of this line? It would be y equals something. If this is a 2 right here. Okay, so horizontal line, the equation is y equals 2. It's a horizontal line. Doesn't matter what x is. If x is 1, y is 2. If x is 2, y is 2. If x is 3, y is 2. If x is 0, y is 2. Y will always be 2. So in this case, that's considered a constant, right? It's a constant, even line. It doesn't go up and it doesn't go down. So what do we know about the slope of a horizontal line? What's the slope of a horizontal line?
0.
It's always 0. So the derivative is 0. Okay, the derivative is 0. So if you had an original function that looked like this, so let's say we had 3x to the 4th plus 1, and I wanted you to find the derivative of that. Well, you do walk through your process, drop this to the front and multiply, and you get 12. And then you're going to subtract 1 off of the original function. So you get 12x to the 3rd. This constant is, remember, you find the derivative of each term. So the derivative of 3x to the 4th is 12x to the 3rd. The derivative of 1 is 0. So you don't even need this. This part you don't even need. So if you have a constant, the derivative is 0 and it just gets dropped off. Okay, that's this rule right here. Right, the power rule we already know. Drop your exponent to the front and multiply, and then subtract 1. Okay, the constant multiple property, all this means, I'll give you an example of it. All this means is if you had the function, you know, 1/2 x to the 6th power, right? All this means is I can take the 1/2, not off, but move it to the front, and then I can still use that property, right? Drop this to the front and multiply. So times 6, and then x to the 5th power. So we've actually been doing this constant multiple property already. We just combined it. So they're saying you can move it to the front and then find the derivative of the x term, or you can just combine it. So 1/2 of 6 is just 3x to the 5th power. So this part right here, we've already been doing it. And then this sum and difference property, all that means, and we already did one of these, is if I have an original function and I have, you know, all kinds of interesting terms like that, I just take the derivative of each term. That's all that means. I find the derivative of this term, I find the derivative of the 2nd, the 3rd, and the 4th, and then I put it all together. So here is something that you want to be very, very careful of. If you see a radical, your first step is to rewrite it, and then just continue. Don't find the derivative of these yet, because what I have seen happen is a student will change this one, and then define the derivative of the other ones. And so you have a mixed bag of a function. Okay, so you always change the radicals, rewrite the entire function, and then find the derivative of each one. So drop this to the front and multiply. So 1/2 times 3 is 3/2. And then I subtract 1. So to the negative 1/2 plus, drop the 3 to the front and multiply, and then subtract 1. So I get 6x squared. And then drop the 2 to the front and multiply, and I get negative 6x to the 1st. And then this just goes to 0, so I don't even need it. So that is the derivative. And so that's what that sum and difference property means. You just find the derivative of every term that you can. Okay. All right. Any questions? You're going to get lots of practice today. Okay, so here's what we're going to do. I'm going to put you in breakout rooms, and here's all the rules, what we just went over. There's your power rule. That's what you're going to use the most. And I just want you to go through, and in your group, there's 12 problems. This won't take very long at all. There's 12 problems. all right? I want you to go through as a group, and you can do it a couple different ways. One person can have this, you know, your screen shared and you can see it, or everybody can use this, you know, go into your class and open this. So here I fixed it. Here is where your OneNote is. It's right here. It's at the top. So if you go into your Canvas class, open your OneNote link. There it is. It works. And then go to the second homework 5, basic differentiation practice. And that will open up the document I just had. Okay. So either one person can share it and you can all kind of, you know, work together on it, or you can do it individually just on a piece of paper, and then double check your answers. Make sure that you are talking to each other and make sure that you are helping each other walk through the process. Okay. And then I'll give you probably 15 minutes in your breakout rooms, and then we'll come back. We'll see if there's any problems with them, anything that I need to answer, and then we're going to jump into marginal analysis. Okay, so I'm going to stop sharing. I'm going to make sure that everybody can share. Okay, all right, let me get the breakout rooms. We have 16 people. So I'll do 4 breakout rooms and I'll just randomly put you in. Okay, any questions? All right, here we go. Go into your breakout room, introduce yourself, talk to each other, see how everybody's weekend was, and then jump into that document.